Yeah, thank you so much. And thank you, Richard, for introducing us to the folks at NXTBLD. We really appreciate being here. So we're going to talk to you a little bit about something that is slightly different from BIM, but really just kind of grounded in our mission of sustainability at our practice, and specifically our experiments that we've been working on for the past year or so that are really been focused on one magical biomaterial, and that is mycelium. So the question is, how do we rejoin nature through constructing the architectural symbiosine? Right, so little did we know we formed a band just about a year ago when we embarked in this endeavor. This is our 5-piece band, and I think, so this was taken just a few weeks ago at Clerkenwell Design Week, where we installed our mycelium bricks. And I think something that's really important to note here is that everyone in this photo and everyone that was a part of this project comes from a different and very diverse set of design disciplines. So we have industrial designers, that would be me. We have architects, that would be Jen. We have computational designers, that would be Abhinav. Model makers like Ram, and even urban studies. And I've just learned today, well more than that, computer science, Savannah in the back there. But loads of diversity in terms of the various different trades that we brought to the project. And I think that multidisciplinary approach was something that was quite key in the success of realizing this. So before we get into it a little bit more and we speak a little bit more about sustainability within our practice and, of course, mycelium, I'm just going to talk to you a little bit more about PLP architecture and PLP labs and how that's kind of structured. So this is us. We're about 150 people. We speak over 45 different languages. We're 35 different nationalities. And we undertake projects globally. So we work all over the world, hence why it's quite critical for us and fundamental to be a very diverse practice. In terms of offices, so we're based here in London, but we also have offices in Tokyo and Singapore. And this is kind of a good way to understand the overall structure of PLP. So on the left-hand side, PLP architecture, which covers our standard design practices and services, to PLP labs here on the right-hand side, that is more of our research and strategy group. And that could be anything from developing tools in-house, so digital design tools, to future mobility systems, and even experimenting with new materials. Right, so in terms of PLP architecture and the various different sectors that we cover, anything from the largest scale, so master plan. We really like to focus on this idea of a life-centric approach when we design our master plans. And we do a lot of this. We do a lot of workplace. And we are really centered and grounded in the idea of trying to make the occupant actively engage with the space and activate the space. To residential, so our ideas around how we can redefine what urban living means, to hospitality, and even most recently an industrial design department that we've opened up just a few years ago. And I think that multi-scale approach has been not only really informative to our products that we're developing, but even to the wider scale of things, to our master plans, right? So there's been a really interesting dialogue there and discussion between scales. So a little bit more about PLP Labs briefly. So Labs is essentially our research collective. Labs was set up back in 2016. And I think really for the simple and fundamental reason of why Labs was set up was that the world doesn't exist in silos, and neither should our architecture, right? And our work should truly reflect that in some way or another. So what does that mean? Essentially, we work across the intersection of planet, people, and technology. And just the various different collaborators and partners that we tend to work with. So that could be anything from the academia space, such as the University of Cambridge, to large tech companies such as LG. And that is quite important to the ethos of Labs, is having this really mixed bag approach of various different collaborators. And these are just some of the recent projects that we've done at PLP Labs. We'll get into a few of them. I'll let Jen and Abhinav speak a little bit more about them in a second. But essentially, you can see here how they're reflected across their respective verticals, right? So when we're looking at Planet, we're talking about how we can experiment with new biomaterials such as mycelium, or even looking at timber and how we can utilize that in high-rise construction. When we're looking at people, we're trying to understand how we can create fairer and more resilient cities. And technology, how can we harness new technology to create smarter and more sustainable cities? Right, so now I'll hand it over to Abhinav, who will try to explain a little bit more about the Symbiocene and exactly what that means.
So, looking at PLP Labs' focus on the planet, its people, and their technology, our narrative goes to the very beginning, to the Holocene, when we first began forming communities and whatnot. And fast forward about 10,000 years, we are here now in the Anthropocene, looking at untethered urbanization and industrial growth, which with majority of it happening over the last century. So we all know and fully understand that finite resources cannot sustain infinite growth. And if you have been feeling a sense of growing dread over the current ecological crises, and you are not alone, because solastalgia and eco-anxiety, they've been classified as psychological disorders in the last few years. So, being the most accomplished ecological engineers this world has seen, we need to make a conscious effort to reevaluate our relationship with our natural environment. And this means developing new systems and frameworks to essentially redistribute our very limited resources that we have, right? So we hope that the next era will be the Symbiocene, where we can exist in a symbiotic and productive relationship with our natural environment rather than a parasitic and extractive one, right? And I hope we can all phase into this next era together, and soon. And some ways in which PLP, and I'm sure a lot of us, try to integrate the ideas of sustainability and ecological optimization into mainstream practice is through various forms of analyses and evaluations to inform our design decisions. This includes a lot of well-known analysis tools which we've seen throughout the day, as well as creating these sort of digital twins, which let us communicate effectively the impact of our material choices to our collaborators and clients. And I'll let Jen talk a bit more.
So these are just a few examples how we implement it into our practice. We always aspire to include sustainability thinking and tools into every project we design and build globally, from biophilic gardens of Park Nova, creating literally a park in the sky of Singapore, to Bankside Yards, which is under construction right now, near Tate Modern, to become the first UK's first major mixed use fossil fuel-free development, to Park Romana, which is in Milan, which uses natural based solutions such as suspended forest to mitigate heat islands and minimize flood risks. So we've done energy and smart technology and the Edge building in Rotterdam, which was one of the most sustainable buildings at one point, where the users took control over the building itself to boost its efficiency. We've done embodied carbon in Tower 10 in Amsterdam. There is a 22,000 square meter structure, existing structure inside the building. And we're doing urban ecology in a treehouse in Rotterdam, which is pioneering bio-based and recycled materials. We should all learn from Netherlands. So we've done energy, we're learning about well-being, and carbon, we're a long way to go. So what's next? We can't continue in the same way. We can't continue building with concrete and steel. So we need a change, and Symbiocene begins with an intentional design choice. So we can either step out of the equation and basically take control over it, or we get killed and become extinct, and planet will carry on, and there will be life again in 20 years. So we can either start proactively working with it, or it's not about trying to protect our planet. It's actually actively engaging with it and embracing it by using technology to work with nature.
So this brings us to the most granular scale that we work with as architects and designers, which is materials. And we'll look at answering a simple question of how we will build the symbioscene. So a lot of our research over the years has looked at timber as a relatively sustainable building material. And through our collaboration with the Center for Natural Material Innovations at Cambridge University, we co-designed a pavilion for the London Design Biennale in 2021. Unfolding was on display at Somerset House for the duration of the Biennale. And we worked closely with the team at Cambridge to create a flexible interior partition system made of wood based on the techniques of origami folding and kerfing. There were 6 foldable partitions that were generated through origami, and flat timber-based sheet materials were made flexible through kerfing. And throughout this project, we developed computational models in-house, while the physical prototypes were developed at the university's facilities. And here are some of the prototypes that looked at looking at the amount of kerfing versus the curvature required to produce these partitions. And this installation is proposed as a proof of concept for internal partition systems that can change over time based on the ever-changing requirements of the user. Whether you are single, married, with children, divorced, or whatever, you can use these partitions to reconfigure your space for your particular living situation. And the next iteration of this system, which is more practical and less sculptural, is on display again at Somerset House this year, till the end of the month, I think till next week, as an interactive installation called Ephemeral. So maybe in the symbioscene, we don't need to constantly keep moving houses or build new houses, and the ever-evolving living conditions can be accounted for by adaptable and flexible living spaces made from natural and locally available materials.
Yeah, so I think here you can really see how we go from that hands-on approach, in this instance experimenting with timber and applying that knowledge to our building practices. So here what we're proposing is timber and high-rise construction, and specifically utilizing materials such as CLT for the flooring and GLT for the structural columns and beams. And this is just an animation that's demonstrating how one of these towers could be built. Right, so a little bit more into the process in determining if this was actually feasible in any way. We did various different testing, from full-scale prototyping, steam bending, fire testing. We even ran a series of structural models to realize that this is possible, right? And from there, what we did is we expanded that idea into 3 different proposals. So I think what we were really focused on is the idea of, just pushing the boundaries of this material, right? What are the new forms that it can take on? What are the alternative construction methods that it can take on? So here on the left-hand side, I think, we were also concerned with the idea of how these timber towers could be used for different spaces. So from the left, something for office space, to the center, which is something more geared toward residential, and even something more mixed use on the right-hand side.
So springing off from all of these previous collaborations that we've had with universities and engineers, we're trying to take our first steps towards formulating architectural systems purely based on biomaterials. And we have been in conversation with an exciting mix of individuals and companies, ranging from philosophers to biologists. So mycelium is essentially the root system of the mushroom, but we can consider it to be the actual living organism, and the mushroom being a consumable byproduct produced during its life cycle. Mycelium grows in symbiosis with its surrounding organic matter and binds together a loosely packed substrate into a fibrous composite material not dissimilar to chipboard or MDF. And the properties of this can be fine-tuned according to the substrate we feed it and the growing conditions. Thus, the resulting material is fully biodegradable, potentially self-repairing, produced from locally available organic waste, and has a high strength-to-weight ratio, while also having an excellent acoustic and insulation properties, and fire retardant. So that checks a lot of boxes, for all of us. The production is fairly straightforward. It involves creating a sterilized substrate, inoculating it with the mushroom spore, growing it within a formwork for 2 to 3 weeks, and baking it off to halt the growth, which results in a harder and reasonably inert material. And these are some ways in which it's being used right now in the industry for packaging materials, acoustic and insulation tiles, various forms of wearables, and small-scale installations. In our case, given our limited resources and lack of a sterile lab space, we purchased some ready-to-grow materials and set up a temporary myco-lab in one of our conference rooms in our office. The black boxes were used as grow environments for the duration, and then the blocks were then stuck into this indoor greenhouse tent along with a space heater to dry them off at 30 to 40 degrees. We started off by creating a number of blocks that were tested out by drilling and slicing, and we quickly realized that whilst this can be done while the material is still alive, in the dried out state, once you tear through the outer skin, it becomes prone to fraying. So we tried combining it with a lot of wooden and various organic elements and even timber-based 3D printing filaments. And these experiments were taken forward towards trying to create modular shapes that can combine to make walls and furniture, etc. But we found that once the composite has dried out, it loses about 60% of its weight and it drastically shrinks due to loss of moisture that it holds while it's growing. So we leaned towards this novel system of 3D printed wooden formwork. And upon drying, the shape does not shrink as the wooden 3D print holds the structure while the mycelium binds it to the substrate. And you can see some more examples of interlocking modules, which were all created with this system of 3D printed formworks. And we even experimented with growing it onto organic fabric through a bespoke process, which can lead to some interesting effects of light and shadow. So from the start, we were interested in creating something that can be used structurally in architecture, and being able to create 3D printed formworks that will bond with the mycelium really helped us out in testing complex geometries. And here you can see a series of samples created over a period of 10 months. And from the left to the right, you can see how we evolved from simple blocks to more complex forms and shapes. These are some more pictures. And in this time lapse kind of shows the mycelium growing on to the 3D printed wooden structure. And you can see it's bridging and closing some of the gaps as it's growing.
So as Abhinav mentioned, this was our eureka moment when we discovered that mycelium is happily growing on the 3D printed wood. And for us, it was a perfect representation of symbiocene concept, where basically human, the 3D printing, successfully collaborating with nature, mycelium. And so we wanted to share our discovery with as many people as possible, and our symbiocene concept, because it would only take, our research would only take significant meaning if the daily user can start seeing how these biomaterials can actually enter our everyday life and households. So we started the production and the design for the Clerkenwell Design Week. So we know that a cast brick of mycelium roughly has the same compressive strength as an adobe brick or a cinder brick of the same size, but weighs a lot less. So our discovery of 3D printing an ultra-thin wooden shell and growing mycelium within it gave us 3 astonishing advantages. The first one is the further durability of the brick. The second is precision intolerances. And the third one, control of a more intricate design. So from a 3D printed wooden shell to a grown mycelium brick, where the wooden shell acts as a sacrificial formwork, and you would wonder why the holes in the brick, and the holes are for the connecting pieces, the wooden dowels that connect the pieces together in the 3 ways. So there are 3 joints. That is very simple. It's literally a straight, a turn, and a twist that gave us a very large variety of configurations, which is a very simple system to understand and assemble for everyone at home, from a stool, a table, and a partition. And in fact, it gave us, furthermore, almost an infinite number of configurations that we even discover them daily, from children furniture to shading devices to different kind of design of partitions, seating, tables, and even outdoor furniture. Just to mention, it was a conscious decision to introduce a new material in a very simple, relatable brick form. Because if you introduce a new material and a new geometry, it might be a little bit too alien for a daily user. See how these biomaterials, Mycelium especially, can enter your household. But of course, we're just at the beginning of our journey, and Mycelium will take its own design aesthetic eventually, like concrete or plastic did. So inside the 3D printed shell, we have 3D printed channels in order to feed and lock the dowels inside. Then the shell gets packed with wooden chip substrate with inoculated Mycelium spores, closed with a lid, and off into the growing chamber. Once it's grown and dried, you can start assembling it into configurations with dowels, as you can see one of the configurations in the animation. So behind the scenes, in our meeting room 7, mushroom 7, turned into Mycelium factory, you can see our hard work of preparation, sterilization, and packing of the bricks. And eventually we would like to discover an option of using our own office waste as a substrate, such as outdated prints or used paper cups, in fact, any organic matter. Here you can see Abhinav taking a grown Mycelium brick out of the growing chamber. It has a very fluffy texture, almost cloud-like, and he's putting it inside the heated chamber in order to stop the growth. So over the production time, we actually gained a very good control of the texture and the pattern of the blocks, as you can see them going around, creating us very beautiful, almost marble-like effects. And the pattern and the texture depend on the length of growth and the microclimate within the growing chamber. And of course, we wanted to show you what happens if you don't stop the growth. Mycelium will fruit. These are blue oyster mushrooms, and for the production of our blocks, we actually used reishi species because they're a lot more durable, but they don't fruit. So we're showing you blue oyster.
Yeah, so as Jen mentioned, we went from making just a few of these within our makeshift lab, be it one of our conference rooms, to making a lot of them. So we made about 85 of them, and this is them just delivered right before install at Clerkenwell Design Week. And you can see here, this is just a clip of right after we installed them. So yeah, from anything from partitions to tables to stools and planters with integrated seating, you can see the versatility of just this one single modular block, right? Here's just another overall shot of the Symbiocene living, or we like to think of it as our demonstrator of what that could be. And something important to note here, so yes, we did luck out with the weather. It was sunny for the 3 days that it was installed, because these are, you know, natural materials at the end of the day. But something that we've been recently exploring is bioresin. So bioresin such as tree sap that you can actually coat the mycelium blocks in, and that will protect them from external conditions and weathering. So there's various different commercial products on the market right now, such as street signs, where they're actually applying this sort of application to. In terms of internal use, if we're talking about acoustic paneling or thermal insulation, they hold up just to any other standard, you know, industry standard in terms of durability and longevity. So be it fabric or what have you. And then the most beautiful thing about the whole process and working with a biomaterial is the fact is, you know, 10, 20, 30 years, if you have these fixtures within your internal setting and they feel outdated, you want to get rid of them, you can just chuck them back into the soil. and they'll become one with Earth again. So they'll fully biodegrade. So there's something really beautiful about the circularity of that, right? Oh, yeah. And here's just one final clip of the actual opening of the installation. So from kids to friends and colleagues and just random people passing by, there were a lot of puzzled faces. You know, some people asking us, is it made out of ceramic? Is it made out of paper? I think one lady even asked if it was made out of used baby diapers. So regardless, though, you know, I think from point A to Z, it was incredibly rewarding to, you know, push our experiments and share them with the world and share, you know, what this magical material, you know, its potential that it has, but really open up a larger conversation like we are right now with you about sustainability and the idea of biomaterials. And really, we just need to pursue them further. That's really it. We know how to do everything else at this point, whether it's AI or the metaverse, right? We've pushed the boundaries and the envelope, so we just need to invest the same amount of resource.
So what's really next? For our in-house exploration, we would like to explore self-healing properties of mycelium and, for example, how big of a gap it can breach onto itself, as you can see in this short time lapse, which is playing or not really. Also explore the mycelium fabrics, but mainly and most importantly, we need to start properly getting it tested and certified, because currently there is no proper system in place to test biomaterials, and that's essentially what's preventing us from using it in the construction industry. Because to be really honest, at the end of the day, humans are the best bioengineers. 96% of mammals are humans and livestock, and 82% of birds are chickens. So why don't we use our knowledge and power to help ourselves and the planet and start implementing it into the built environment? Thank you.
Thank you.